same values. The fuck? Yeah, the old static warning isn't really working. I think I'll remove it from expression. Yeah, it would have been super serious, but they called it so fast that this particular thing is not going to have much impact at all. Arch wasn't affected, which I'm running. This was my solution for the problem that I had, by the way. The rest was just the usual refactoring again in order to find it. Comments. Let's remove these comments. I'll remove this one as well, I think. Which file is this? Multiply, I think. That was all. Okay, VI multiply.h. Hey, Abhishek. Yeah, I'm doing reasonably. Pain on my back and stuff, but static assert. Unexpected 0. Do I leave this in? For now, maybe. No, okay. Git commit. Well, the symbolic test suite still works, of course. We're working on this one, which also still works. As in, you have that's the correct value, and this is the new value that was calculated. And that has been done, interestingly enough, by calling QuadraticArcLength on here, which is using all these functions. And I rewrote the top one. Yeah, this one. So this now is using symbols. I'm just assigning existing symbol and then evaluated expression. I think this should work. Shall I leave this in to show what the old code was? Probably not, because maybe keep this comment. So yeah, that is a point though. If they do not exist, sorry, do not depend on these two values, then why is it here? I should assign them at the moment that m coefficient changes, which I think is only in the constructor. Let's try that. Ja, dit is just a copy. It's a copy from the Bezier curve. So I might as well do that here. And then of course the same holds for the other two, the y values. Let's see where those are set. And that, well, the underscore is gone, but this, yeah, clearly. So let's do this one next, as in currently it's runtime. And I'm going to change this into I only need to assign this once, really. Actually, I don't need this at all anymore. It's just, you know, no, don't need it. Well, you know, I need it because currently, the old code works with runtime evaluations, doubles, and it's going to call this function. So as long as I call that function, I need it. Suddenly it's not. What the F? Why is it not called? Yeah, what? Oh shit. So maybe this isn't even used yet at the moment. Huh, what? So confused. V0x, if it's not used then yeah. What did I do then? What did I change? It's not called. Okay, that sucks. That sucks. Well, that means that I can comment these out because they're not used. Can I not? V0, X and Y. Sure. Yep, still the same value. It wasn't even used. Well, okay. Then what is used? Start at the bottom. This is being called. That calls the enumerator, which calls these functions, which calls therefore the log, which calls this function. This function is called, right? Let's just test it like that. Must be called somewhere below this. It is from the log. This function called. Yep, also from the log. And this function called from the enumerator. And this function is called from also from the enumerator. And this is called from also from the enumerator. And this is called from here. And S is also called from here. And Z is called from here. And A0 is then called here. A03 was called, right? Yeah, here. A0 is called V0. Is V0 called? Yep, here. And V02 as well. Is A02 called? Yes, here, and there, and there. Okay, what's this called? And this one. This one is not called. Okay, I think the reason is that I'm using length squared on A0 directly. But I can't take the derivative of that then. So I'll have to replace this with actually squaring these values. That is, if that value depends on my angles. And then the same here, right? I commented these out, but the reason is that I'm using length squared. Well, this is V0, X and Y, so I need the square of these two. And they do depend on the angle. So I can't do this. Let's reinstate this again then. and then actually use it by replacing this line. So this should actually be the square of Vx0 You gotta be kidding me. I don't have my angles. So confused. I can't even call them. Life is complicated. I would like to do this in steps, so pass, one function at a time. But I need my angles in, and this thing is called from all the way down. So that means that in the end I'll have to pass those angles to quadratic arc length. I kind of forgot what those angles were, or where I can get them from. V0QA, what the hell does that mean? Oh, yeah, there. It's whatever was passed to quadratic form. Hopefully I'm calling that in. It's alpha 0 and alpha 1. Let's hope that is the case. Now we are here. This is where we are. So it is these values. arc010 and arc011. So we can pass those here. And then we can do it in steps for now. Those are doubles, obviously. I don't know why they have been named differently every time. Like A is an angle, I'm pretty sure about that. V0 is probably... I have no idea. I think it's the angle between the vector V0 and Q. Oh, that makes sense, actually. Yeah, okay, I'm gonna call it like that. If you run the program again, you see it pop up with the window that probably shows what Q is. So yeah, they're the entry and exit velocity vectors. V0 and V1. So I'm going to pass these to every function upwards. Or I could just store them temporarily. Yeah, in the end I don't need this, so let's store them in QuadraticArcLength, and then I can just access them as just, well, you know, temporary test things. I do have that though. I do have this, so I have to rename them then, or something else then. Let's say test double, whatever. So then it also no longer is super required to pass them here. And those whole functions. So, well, they are member things, so let's add an underscore. So I'm going to assign them now in this function. And then, well, I have them as member variables. Or I could just store them at the moment I call from. But this is just a test, so let's not do that yet. Temporary variables. So now I have them here, and I don't have to pass them all the way up from function to function. In fact, I just have to assign them to this. Well, for this one anyway, yeah. So I don't want to do this here either, actually, not really, no. Let's do tip. Assign him there as well. And now here I can call, no, sorry, here I can use my test values. So these are gone now. Don't have this anymore, this variable. But instead we have a test underscore in that variable. Same there. So now I can replace my length squared with the square of this plus the square of the other one. Yep. And now at least I'm using this actually. So hopefully the value is now still the same, otherwise more debugging. Let me see if it is correct. No, it looks correct. Except of course I wasn't even using this function yet. So hopefully this is correct. Because that's kind of new then. Tja, it compiles. Unbelievable. But what about running it? Okay, so you see what Q is. Q is just the line between P0 and P1. I mean, these are two Bezier curves. This is a Bezier curve, the thick black one. And I think that's what we are calculating the length of. This is just another one, so you can ignore that. So then you have a V0 is the velocity vector at this point. It's obviously tangent to the curve here. I don't think I draw V0. And that makes an angle here with Q. So that would be the this green thing here. Yeah, that's the angle, the V0 QA angle. And then this green thing here is the angle between Q and the exit. Sorry, the green one. The exit velocity, which is obviously downwards, like this. There's velocity here. Can I drag it? I can even drag it. And then drum ruffle, where the hell are they? There, yeah. So it should be 4.4 and the new one is not a number. Fuck. Something totally went wrong. Can I even get a number out of it all? Where is my old new? I don't see them anymore. There. It's not a number all. Oh, there's a number. It's definitely not the same. No, it's not a number anymore. Here's jumps. No, it doesn't jump. Anyway, the values are completely different. Where do I need to go? Here? There is no here. No, just here. No, like I said, this function wasn't used before, and I'm not sure that the velocity is calculated correctly from the angle. So yeah, we have the angles, but let's begin with using the old formula again. So not this, which I'm working on, but the code that used to be there. Sorry for the small font. What am I looking at? Yeah, I forgot again. No, it was this, but then the CXX file. Where's the CXX file? That was, well, it's not mentioned and it's not there. QuadraticArcLength. Yeah, I just removed it. I don't know when I removed it, but this is the code. Show original. Just copy it. Probably disappearing if I leave this. Oops. Back to the old code. Yeah, John, no, because I don't do anything else. I'm bad at managing my time in that I'm not even going to bed in time or out bed in time. Hello, Lance. Quadratic equation. No. This is just something a little bit more difficult. Fuck this. Shortest arc length. Hey, the values are the same. Nah, that's unbelievable. So the formula was correct anyway. I'm happy with that. To be 100% sure, let's fuck it up. See if then indeed the values change. Let's say, is this used is the question now, you know. If I make this 1.5 instead of 2. No, it's not a number, so that's pretty different. No, okay, cool. Cool. So this is correct, but if I replace it with evaluate v0x, it is not correct. Why is the question? Well, fortunately, we can just print it all out. Isn't that awesome? Like, let's put it at the top. D out, DC, notice. Okay, I'll flip the book up. Yeah, what? A second ago it compiled. Like literally 2 minutes ago. Cosine has no S precedence. Well, if you say so, but I'm mostly confused about why it compiled a second ago. Well, maybe this is because I'm not calling evaluate, but I'm calling I want to print it. Okay. Symbolic cosine. There's no cosine to do functions. Yep, does not have precedence. Sine does have precedence, but I was too lazy to add it to cosine as well, apparently. Symbol's good enough. Yep, okay. Make. Now it compiles. Very good. And then we run it again. To get. And it's called 4 times. The formula still is the same every time, obviously. So this is the formula. And it is using, just copy it, a lot of variables. It's not using any other formulas because I don't have any other formulas yet. This is the first one that I'm testing here. But it has variables. Q1x, alpha 0 and 1, and n1x. And we can print those as well. We can print the values of them. Put that here. So Q1x, I can just say the variable that I'm actually using. We inside the thing anyway. Q1x is evaluate Q1x. And then the same for n. And the other variables were alpha. But alpha 0 is actually V0 QA. Why is it called 4 times though? Oh, because it's just called 4 times. Never mind. I should cache the thing, I guess. But everything will be resolved in the end. Once everything is symbolic. Those are some nasty simplistic values. Obviously alpha 0 is not 0. I mean, this angle, totally not 0. Looks like it's rounded off to the nearest integer or something. Really, really, really? Why? Okay, let's, well, that's probably the problem, but now I'm here anyway. I want to check if the formula is correct. So first, so let's go here. Now the question is if this formula is the same as what I'm doing here. Oh, well, how do we do that? I guess I make a copy and then remove the return and then replace test. That would be alpha 0. Could have filled this one in. Two times Q times sine times inverse. Or does it would be this inverse? I think it's multiplied out, right? So this is it's doing this times. Well, let's first make this inverse thing here. This this sine to the power minus 1. Of course, we were dividing by it. That's not necessary. And then this is written as this times that one plus, and then again this times that part. And then we can move the Q1 to the front. And the N1 as well. And the STD can be removed. Now, does it already look like the thing at the top? Okay, let's put the minus alpha in front. Well, this is principle the same thing, right? And then here we have, oh wait a minute, but this is sinus alpha here. Yep, so the sinus alpha is moved up front. And this one was again rewritten a little bit different. So yeah, the formula is okay. Good. But the values are completely bullshit. Now, let's pick one, and they'll all suffer from the same, it seems. evaluate of the V0 QA. I have no clue. It's V0 QA is a symbol. Yeah, okay. They are all symbols, obviously. So evaluate of a symbol. What the hell? Here's evaluate of a constant. Here's evaluate of a symbol. That returns me get value by ID on the symbol type. It's definitely returning a double. So the T here is a symbol and then the get value. That's probably the symbol registry, which is the base class of a symbol. Utils, yeah. So it has to be this one, which is returning a double. Then that is returning the value of symbols ID, where symbols is a vector of data. Data is a double value. Now we already tested the name, because if I print, I just call get name, which is doing the exact same thing, symbols ID dot name, and that worked. It prints the right value. So I would say this value has the wrong value, but that is being assigned here. So maybe we should start printing what we assign. That is going to help, I think. Assigning, I can't type anymore. How do you print assign? Assign there. Assigning the value to, and now I want a name. I'm not sure if the name is already set at this point though. Yeah, definitely, that's already set. Okay, just do symbols name. Let's see what that gives us. So here, so totally being 0 and -2 are being assigned instead of the correct double values. And here it went wrong as well. Yeah, I guess a breakpoint at this position would help. Or I can do it manually, look where set value is being called from, and so on. Breakpoints are annoyance. Set value. I would say this one. Int value. No, we found it. the fuck, yeah. Really, seriously, sorry for the F word, but yeah, that should be a double. Hello. No, it's great. The same value, yeah. So I think that was it. Pretty cool. Let me drag this a little bit. Yep, still the same value. Okay, let's remove all this junk again. So now I should be able to do return evaluate instead of this code, which I won't delete just yet. And it works, yay. Oh, wow, finally, man, we are getting somewhere. Okay, now I want to do the same thing here. So now, instead of doing this, we start with doing a return evaluate b1x. Well, it doesn't exist yet, so I'll have to define that one. The const expression lambda, which then we call, and that thing returns something that is much like where we just came from, Control T. So this, but these are already assigned, or they are not, but they should be. Maybe we should do that first. What is also done here? Is it not? No, it's done here. Yep. So I have this one and that one. That looks good, right? So Q, X and Y, and the N X and Y are just defined right there. And then this is really pretty exciting, because what this gives me in the end is that I can calculate the derivative. I type it in, I define it now in terms of a symbolic formula, which I can evaluate here, which then, when I'm finished and everything is replaced with symbols, I will be able to do to get the derivative by partial derivative with respect to these two angles. And that formula, that derivative, is pages and pages long. It's so complex that it was impossible to convert it to a C++ function. So yeah, if that works, then it was worth 1 month time of work on this formula stuff. I'm finally getting closer. So instead of doing this, we now make it symbolic by doing auto. This is some formula type, and this is the constant 2 times the sine of V1Q divided by the sine of V1QA minus V0QA. Return It's the same thing. I can make a probably, should I? Nah, doesn't matter. I mean, I can make this a separate variable, but it's all compile time anyway. So maybe it would compile a little bit faster, I don't know. V0 Q1 diff times the cosine of, why is this so the same? Just this Q is different. The Y coordinate. Yeah, so almost the same formula. The only thing that's different is the Q variables that are being used. Yeah, well, why not? Let's you change this. Let's add a new variable. Although, no, I don't like that. Wait a minute. I mean, I have to give it this a name then here as well. So in the end, I need a lot of those. So, okay, let's do it. Just have to start somewhere. So this becomes a thing on its own. Oh, it's not a symbol, sorry. So I don't have to give it a name. It's just another expression. Yeah, I think so. And if not, then anyway, because I'm now going to try it. Apart from that, I can't type evaluate. No, if it compiles, then it works. You know that. Should know it by now. Same value. Yep, still works. Well, that was this one and that one. And now do the next one, right? I think I'll just have to do all of them, one by one. Probably want to do all of them. Yeah, I think I want to do all of them. Okay. How the hell did this work? Because it doesn't look good. I called it V1X. It should have been V0Y. Haha. But okay, I guess that doesn't matter. That comment clearly says that it's just V0. I don't know where I got the V1X from, but V1X should have been V0Y. What, just the wrong name, but the rest code doesn't change. Yep. You would think I need the same formulas for the V1, right? Well, it's not the same formulas, but also a V1x and V1y. Don't see them though. Oh, that's probably because maybe, you know, like square length again somewhere. A0, V0, or not. It seems that the V1 is completely out of the picture. Completely. There's no V1. You have to accept the universe the way it is, I suppose. Okay, then do this one. So this now must be replaced with evaluate. V02 underscore. Do I have to define V02 underscore? That is, if this is going to work, it's like, again, shocking. Because util square is going to call. It's not a float type. It's where a debug tensor. It's not a built-in. Oh, it's interesting. I have only this. It must be multiply assignable then. So maybe it won't even compile. Yeah, this and the whole square is not const expression. Nah. Maybe I can't use square. Or I have to fix util square to also work for const expressions. Anyway, I had expected it to do this, multiplication, and then that multiplication is going to call multiply underscore t, I think, yeah, the struct, or instantiate the struct, which then detects that the two template parameters are the same type, and then convert that into an exponentiation to the power 2. It's like way difficult stuff. Yeah, I don't think this util square will compile, but I insist on being able to use it here, so I'll just fix it. And then we don't need these two anymore. Pretty sure these are they were already not called before. Yep. Yeah, just there is no square here. And that is because there is no, whatever this is called, multiply a sign. It also doesn't make any sense to define that, I think. So I need something that works when this is not defined. I'm wondering, this can't be a cons expression, can it? Can it be a cons expression? No, this is clearly a runtime changing result here. How could that be a cons expression then? Well, am I completely crazy? Anyway. I need another one which has as requires that it is not I'm confused that there's no parentheses around this. Is that not necessary? I thought it was necessary. Is that only for strings? Let's try it without then. And here there are parentheses around it? Dude, what the fuck? Make up your mind. Yeah, so here I'm gonna really make this a cons expression. No, this is nonsense. This would be conceval because it's not going to work with non-cons expressions, right? If I don't even have the argument, then there's nothing to change, or what? No, then I have to instantiate it. I don't want to do that actually, because it's also not possible. Damn it, it's not easy. Well, I want to do the same as here. But then I need my arguments. Although, yeah, I don't know. Let's do this. See, parentheses are required around this expression. Maybe it's because of the not. What if I put it around everything? Is it then possible compiling or what? Then the compiler crashed. Don't have time for that. It's probably illegal code anyway. I'm going to try. I'm first going to try this. Damn it, stupid compiler. Yeah. Well, I guess I'll do this because I'm not going to make a simple thing. But I can do this, I suppose. Open the top here. Sign in. Really? This is GitHub. Dimp. Sorry, I put it in. Not computer. Tim. There's that. Was it not temp? These two. That was the last one. Definitely was the last one. That one. Tim, quadratic arc length. I don't see it. I don't see it. Things still exist. Totally still exist. TXT. I'll have to make it a TXT then. What the fuck? Okay. The thing is called CPP, but no. Move. Dot TXT then. More holds. What else do we have? The other one. SH. There's also no SH, of course. Chimp. custom files, all files, tpp.txt. I believe that worked. And sh.txt. Preview. No, submit. I don't see them. Why am I not seeing those attachments anywhere? Yeah, they make it too difficult. Let's try to fix it or make it not crash anymore. Apparently a static assertion is fired. Yeah, okay. Keeps crashing. Constraint is not satisfied for class template product. Width E is constant and E2 is multiplication. In instantiation of member function, add equals. Can't make a product when the non-constant factor is a multiplication. Yeah, of course not. I'm even trying to do that. Maybe I should just use multiplication actually. Of course I should do that. This is again a bit over the top. Variable conversion from a returned value of type what? Do I not need to see that? It's already grown too big, it seems. I'm just getting started. Shit. Differentiation of income translation Newton square. Just one type, right? Oh, I get it. Yeah, yeah. The type is not a T anymore. I have to use auto. Hopefully then the compiler crash will be gone as well. Hopefully. Looks like it. Yes. Okay, so Now I forgot what I was doing, but let's just run this program again. Now it still works. This value is equal to that value. Meaning that we can get rid of this. No need to evaluate that. So this one works now. Well, this is V02. Which is currently evaluated there and there and there. Okay, just need to keep that one a while. Let's do the next one. A0x. So this must become evaluate of a new variable, ax underscore, which then has to look like this. Q1x. That one is already assigned, isn't it? Yeah, here. Q1x. Oops. Just the same thing. A0x. Q1x, you have that, minus V0x, x coordinate of V0. Wouldn't that be like this? I would think so. I think so. Static assertion failed due to requirement is the same constant minus 1 and constant 2. Two constants. Can only combine exponents of the same expression. In an instantiation member function, make exponential of two constants. No, I don't think so. What the hell do we get there? In instantiation or template class, make exponentiation is there, make instantiation here. So I'm calling make exponentiation on two constants here, which doesn't make much sense. Why are we doing that? Multiplying E1 with the multiplication of E2 and E3. If E1 is less than E2, then it is the smallest of the three. If E2 is less than E1, then E2 is the smallest of the three. And if neither is less, then E1 and E2 are equal, but that holds for constants. In which case, I'm not really interested in calling make exponentiation at all. Now, obviously, we do get here when they are both constants, because constants are considered to be less than anything else. So I should just combine them, I think. Yeah, I don't know. I could make make exponentiation deal with it, I suppose. Keep this as it is. Kind of makes sense, I suppose. Yeah. Yeah. So make exponentiation deals with stuff that is a power of something where the something is the same. So this is base to some power and this is base to some power. And then it returns base to the sum of the powers. But it also deals with when then the power becomes 0, the power becomes 1. And it deals with when the base is a product type or the base is not a product type. And I could deal with when the base is a constant. Let's do that. So the base is then the constant E1 actually. And this fails then, because the constants are not considered the same, of course. So before doing this, I should test if it is a constant. Should I do that here? If const expression is constant E1 and is constant E2, and because it's a constant expression, we have to wrap the rest in else, otherwise it would still be compiled and the static assert would still fail. So in that case, you have to return the multiplication between the two constants. How do we do that? And there must be some kind of shortcut. Could multiply two constants. Or not. Probably not. No, I just want to multiply. It's overloaded. Or specialized for two constants. That compiles again. And the value is still correct. Yay! Cool. So let's do this one then. A0y. Well, that's kind of like exactly the same thing, right? Why? QY is already assigned, and this becomes 2 times Q1Y. Oops. Times V0Y. This can hardly fail. Nope, still good. Next, well, the next one looks extremely much like what we already did. So let's do that. So this becomes return evaluate A02 underscore, and then I have to add A02 underscore. Static cons expression auto A02 underscore cons expression lambda and yeah, A0 length squared is actually going to be just or just the square of AX plus the square of A0y. Yeah, this stands for A0 squared, which means this. No, I don't know what it stands for. That's the square of the length of the vector A0, which is this. And then let's try to test it again, I suppose. It looks like every step fails. It looks like, really? Why? Static assertion failed due to requirement is the same product constant to the symbol. Sorry, what is the same? Product constant symbol, comma symbol. Okay, so why do we get there? Because I don't think I can calculate this one. It is the product of 2 times symbol 0. Oh, actually, yes. And symbol 0. So that is 2 times symbol 0 squared. Yeah. Kind of confused that it was considered equal, but on the other hand, it makes sense. So where do I make the differentiation here? 2 times symbol and symbol. So we have an if less multiplication for a product and a symbol. Product and a symbol, that would be this one. That's the same as the is less product. For a product and a symbol. Which is not defined. Resulting in false. resulting in false both ways and therefore considered equal. So is-less product doesn't really deal with products. No, I have to think. I think the reason is that I think I understand the reason. But no, it's not correct. Something is missing. I think I'm going to say actually it is defined, yeah. No, it's not. Sorry. I think by not being defined, it's like all is less, but I'm also testing the other way around, which then also failed. So we had a product of a constant times a symbol and a symbol, but if you swap them, you get a symbol and a product. I do have those, that is, I have symbol and I have symbol power. The only thing that is missing is a symbol product. That's the one that is missing. See, I do have constant with anything but a constant, but I don't have symbol with anything but a constant or symbol. Constant, symbol, or power. I don't know where to add it, before or after this. It's kind of a catch-all, but on the other hand it isn't. Let's add it here. So template something. Struct is less product symbol product. That one is missing. So we can make this E2 true type. Kind of catch-all then. So a symbol is less than anything, E2, as long as E2 is not a constant and not a power and not anything actually. So as long as E2 is a product. Yeah, choosing expressions with a lot of requirements. But then a power is also less than a product, I think. Just have power symbol and power. So you can do the same thing for the power. Power is less than a product, but is it? Not for the multiplication. I think I have to take the IDs into account again. So assuming it's more complex than that, let's move this one down. Maybe it's more like the base of E1 of the product. E1 is a constant, a symbol, or a power. I think I want to compare them by ID. Then I need expression traits in is less product. That's not going to work, I'm afraid. Or is it? Well, while I'm at it, okay. Problem is that I don't have get base yet here, I think. Let's make it a separate header. I think it's defined all over the place. But I don't need this one. We just need power and the rest. The rest being, I guess, this. Oh, that didn't work. Get base, get base. Oh, shit. No. Get base. 2-need expression. Yeah, so this requires a lot of stuff like symbol type and constant type. Hopefully that works. It's constant is symbol, and then I need power. Power is 4 declared in just power. How can I just include is power? Maybe it works, you never know. Expected unqualified ID. Guess product is not known. Is less product, doesn't know what product is. Still doesn't know it. A symbol is including expression traits. That's probably no longer necessary or working. Or needed. Okay, that's a smart way to do this. Grep expression traits of H. Probably ID range. No, it comes through base class anyway. Differentiation. Yeah, this and also should be moved. Like, oh, this is exponentiation. Never mind. is constant. Also just is constant, it seems. Don't know why. What does it look better? Also is constant. What others is constant? Is symbol. And this is power. Okay, so we need symbol. So I'll do that. Symbol. Precedence ID. Okay. Power. This is power. Okay. Next, symbol type, constant type. Yeah, we have that. Not even sure if symbol is included. Yeah, of course it is. It should be. I mean, expression traits is constant. Is symbol is power is product. Just this product should suffice. Couldn't be kidding me, right? Yes, is product. Hardly really necessary. Well, maybe it is necessary. Anyway, is product. Did I or did I not? I did. No. Apparently not. I mean, symbol does not include is constant. And I said it has to, but no. Why would it? Get exponent. Oh, that is still in in exponentiation. No, in expression traits. Ugh. I'll just have to move that as well. There's no easier way. If I want to define this here, which I don't, of course, might as well give it its own header anyway. Don't need to define it here. Okay, get exponent. Grep source, get exponent. Is defined in power and in expression traits and in exponentiation. Actually, what did I do with the is base? TS get base, I mean. I left that in exponentiation. You mean that exponentiation is including is base, right? No, it's not. Why is it still in here then? Because it uses exponentiation. That kind of makes sense. So, yeah, okay, so let's leave that one in then as well. But still, on this one also here, so not convinced. This one's still using expression traits. But yeah, maybe that is a good thing. Anyways, I made a new header for get base, so let's do the same thing for get exponent. Still confused why this is working then. That didn't fix it. So, what the hell, man, this doesn't make any sense. Get exponents. Where's my get base for the power? In get base. Oh, okay. You will have it like that, right? Oh, that's because I needed it for the is less product and only for less product. So the other one is still in exponentiation. And this I don't really need, so maybe I should leave it where it is then. This being, well, get exponent. It might just work. What? I'm including his products already. What? Oh, his product is not for declaring products. Yeah, it is. Yeah. Okay, that's confusing. Yeah, hello John. And Zivan and everyone else. Ford includes expression traits. It's maybe not the right thing to do anymore then. Though I do need a lot of those, but yeah, not all of them. So include is constant. Yeah, and the rest is product. That should be suffice, or how do you pronounce that? This product. product doesn't know what his last product is now. It's just a static assert. Constant power product and base. Get base. Okay, so apart from get base, that should be no problem. Let's just try it. I hate this header spaghetti. Hello, Abhishek. This depends. Sleep. But is yeah, 4 is not enough. 6 is already not enough. So it seldom happens. The 4 hours happens sometimes, but just because I just don't want to go to sleep. And then I go to sleep like way too late. I had an idea which involved stopping streaming, but I forgot what it was. I probably should go buy food. I don't have food anymore in the house, so Ah, I remember. I was going to buy an ice cream. When the sun was still shining. Yeah, I have to go that way anyway, because shopping. I suppose this can rest. It's just a header. No, it's a recursive header dependency. Addition needs multiplication, and obviously multiplication needs addition, so that doesn't work. It's not really fun either. I'll just stop. Continue later. Thanks for watching out for me, man. Otherwise, I would have had to order out again and eat Chinese food or something delicious. So, no, I think I probably would have ordered a lasagna somewhere. Yeah, I don't have a breakfast either.